A long time ago, long before large language models, long before deep learning or classifiers or artificial intelligence, there lived a mathematician by the name of Andrei Andreevich Markov. Markov invented something that later became known as the Markov chain, which can produce cool things like this. Alice, they sat down. She said, well, okay, maybe that wasn't so useful. Well, how about this? Uh, rabbit sends in knocking and of circle and yeah, maybe not. Yeah, so obviously all of those examples are a little bit nonsensical, but what they all are the result of a very special kind of random text generator called a Markov chain. Here's how it works. Let's look at the words on the screen. There's two thes and one and. If you look at the placement of the words, there's a 50% chance that the comes before rabbit, and a 50% chance that it comes before hare. There's a 100% chance that the word and comes before the. What a Markov chain does is it takes in a text feed. So this example is too small to be useful, but in the previous examples, it fed in the entire text of Alice in Wonderland. And then it builds a table of probabilities from it. Then it makes random chains of words that are probably related to each other. So in our simple example, it might produce the hare and the rabbit, or if you ask for a longer output, the hare and the rabbit and the. Given enough text, a Markov chain can produce things that look a lot like sentences that follow the general rules of grammar, even if they don't make a whole lot of sense. One cool part is that it doesn't take a whole lot of code to make a Markov chain. This example, I'll post a link to the GitHub repo below. If you take out all the comments, it's only 42 lines of code. To summarize what it does, though, it takes in input text and makes a probability table for every word in it. Then it generates random chunks of text using the probability table, which means that with enough input text to work from, the order of the words that come out are roughly what you'd expect from a grammatically correct sentence. People have been using these to make random text generators for decades. Now, the really cool part is, though, if you feed in numeric data instead, they can also be used to generate predictions, things like weather, price trends, even baseball predictions. People have been using them for this purpose since at least the 1960s. Now, you're going to tell me that AI and LLMs have got nothing whatsoever to do with the simple single word ahead predictions of Markov chain. But hear me out for a second. The way that an LLM works is you take a huge amount of data. In this case, we're talking about text, but this really works for anything: images, film, sounds. And you chunk it up into small equal length pieces. Then you feed it into a neural network to train it. When you're done, you feed in an input, for example, text that you type into a chatbot. And the text goes into the trained neural network, plus a randomizer, and it produces textual output. If you train your AI with enough data, and today's frontier models are trained with basically the whole internet, then the output that you get could be mind-blowingly awesome. Basically, though, we're talking about the same sort of thing. In an LLM, the neural net stands in place of the extremely simple probabilistic table of a Markov chain, which can only really predict one word ahead at a time. This means that an LLM predicts further ahead using its training, and the result is that the overall output doesn't just make grammatical sense, it actually makes sense most of the time. The similarity, though, explains why LLMs still produce what we call hallucinations. From a probabilistic perspective of the LLM, these are still valid outputs that follow the rules that were established within the neural network from the training data. And the more data, the more varied the data, the harder it is to prevent hallucinations. So what does any of this have to do with the actual central question of the video? Is an LLM actually intelligent? Is AGI, artificial general intelligence, actually possible? Is it possible for an LLM to be an AGI like so many industry pundits have claimed? Here's a thought experiment. What is a Markov chain doing when it isn't producing text? It's just a table filled with numbers or letters, right? You'd think a neural network is different, and the ones you find in nature are. They're constantly in motion, electrical charges rising and falling all over. An AI, though? I think a trained neural network is maybe something more like a hologram. You know what I mean, right? You move it this way and that, and you can see the picture in 3D. And if you took scissors and cut a small piece of the hologram, If you angle it just right, you can still see the whole image. When it isn't trying to complete text for you, it isn't really doing anything at all. It's that hologram packed with data, and you can pull just the right piece out of it, like magic. But is a hologram intelligent? One more thing. I currently know of 10 different measures that can reliably tell the difference between text that comes from an LLM versus that which was written by a human. Any human. 7 of those measures come from teams competing in a competition. There's a paper about it, and I'll see if I can find a link for you. 3 I can't talk about. Some people I know are working on a patent. The thing is, it's so tricky for people to deal with just how complex, how compelling the output of an LLM can be. It isn't necessary for something to be intelligent or even architecturally complex for it to produce output that you just can't predict. I don't really have an opinion about AI generally. Maybe somebody will build an AGI. Maybe even someday soon. I just don't know. I'm also pretty sure that what we have today isn't AGI though. And I'm skeptical about LLMs, or more correctly, transformer models in general. After all, tools don't have to actually be intelligent in order for them to be useful.